Hi friends, welcome to KSR Datavizon. In today's topic, we see what is PySpark and why we need PySpark. PySpark is a Python API for Apache Spark. Apache Spark is a open source engine which is generic purpose and very fast, and it's a in-memory computing engine. And Apache Spark supports history and streaming process. History data means already stored. Once all the any other data is already stored in any, it can be any format, structured data, unstructured data, semi-structured data, or it can be from any of the legacy systems like Oracle, MySQL. It can be in any format like log files, web logs, pictures, videos. It can be any form of data. It supports to read the files and perform some operations on it. And streaming means real-time data. Real-time data means what? When the data is flowing in currently, like for example, if you are doing a transaction, then immediately the second that you perform a transaction, your account details must get updated with the addition or subtraction of the money that the transaction that you have made just now. So similarly, such kind of real-time data also we can process using PySpark. And the Apache Spark has various APIs to work with SQL or machine learning, graphs, streaming with Kafka. So we have multiple libraries to do that within the same application, same Spark application. And also it's polyglot, means we can write Spark using multiple languages like Python, Scala, R and Java. So if the developer is flexible in Java, he can write the Spark code in using the Java. If he is flexible working with Scala, he can work Spark with Scala. If they are flexible using Python, then they can work on Pyspark. So Spark it's such a very good engine that is developed basically in Scala, but it can be used by any of the developer who knows any of these languages, which are like Python, Scala, R and Java. Okay. So this is the flexible engine that we ever have in the market. Now we got a gist of PySpark, correct? Next, why we need PySpark? There are lot more technologies in the market, correct? For everything we have different tools, different web services, different databases. We have everything. Then why PySpark? What's the main usage of it? That we will see now. Current market trend for processing data. So friends, we live in big data world where out of 100%, 90% of the data was generated in the last 10 years, and it shows the rate at which the data grows. Means, for example, I am telling you, Facebook, if you take, do you know how many posts per minute will be generated in Facebook? In the worldwide, 4 million posts per minute will be generated. Means people are posting something per minute, they are posting 4 million data, 4 million posts, and you will just go and like some picture or some video in Facebook, right? So that rate is 4.5 million likes per minute, means 45 lakhs likes per minute. It's not day, it's per minute. And 350 billion photos are uploaded already in the Facebook. And if you see the Twitter statistics, per minute, do you know how many tweets will be generated? 3,47,222 tweets are generated per minute. And similarly, if you take WhatsApp, nowadays everyone is using WhatsApp. Even businesses are going ahead in WhatsApp, and 500 million new users for every quarter are adding in WhatsApp. And coming to the e-commerce world, Amazon is having 6K orders per minute. These are just 4 basic very big companies I have noted here. Like this, we have hundreds of companies. I should say thousands of companies. Each and every company is having lot of new users every minute or every day. So the data is growing very huge, right? That is the problem now. Like, we have to handle this big data. Big data means data is huge. It's not we are not able to perform anything because of the huge data that is being generated by the people every minute, every second. So we need something which will process or hold the data, and what we will do by simply storing, we have to perform some operations on that, so that we can make use of that data for achieving something for their growth in their businesses. So at the end of the day, we all look for the growth. Even the businesses, they look for the growth. So whatever data that is being generated in all of these formats, they utilize all these things for gaining something, like sentimental analysis. Which is the trending movie? How they will know? They have to check. So see, if you say something is like which movie is good, you have to compare it with something else, correct? For that you need some movies. If you have 10 movies, you can say whether which movie is good, which movie is trending, or if some new movie is getting released in the market, you will see what is the review, and if in that checking that reviews also, you will see which websites reacts very quickly for you, which website has more users given the reviews for that particular product or movie or anything, correct? For anything, any movie or any product, you will see how many users have already used and reviewed. If you want to purchase something also, you will see how many people have come and reviewed that product. And also how quickly you are getting the results. When you search for some movie rating or something, which website gives you very quick results, and how many users have reviewed that. Based on all these points, you will select whether to watch a movie or not, whether to purchase a product, online product or not, or something like that. So all these parameters are very mandatory for their business growth. Okay, so the first one is current market trend. So now we have seen what is the current market trend. Means we have huge data, everyone has mobile now, the two smartphone, everyone is looking for something which they will get quicker results, they will get genuine results, and also like they want to know how many people are already used and how what is the review of the product, I mean to say, whether that is good or not. If someone upload some photo, we wanted to see whether that online product is good or not, because we can't touch that and feel and purchase the product now because of the online usages, correct? So all these parameters will give the current, will set the trend, current market trend for the data. So this is the main, like we have to understand how much we have the data, so that next we will see how to tackle the data. So now coming back to the second point in the why Pyspark module, advantages over legacy databases. So we know that RDBMS is a relational model primarily used for storing structured data, correct? Everyone uses either Oracle, MySQL. Most of the many clients uses these legacy models for storing their data, because that is very reliable and it has very lot of advantages, and they are flexible in working with Oracle or something like MySQL. So most of the people use RDBMS. But if the data is very less, they can perform the analysis using the smart and easier queries. They can write a select statement and they can get the what is the most quick which product got sold most in the recent quarter, in the last quarter which product. Then if they wanted to do that, they can write a simple select query and they can get the results if the data is less. But here data is more for us. It's not in GBs or terabytes. It's very huge. It's in petabytes. It's more than that. We don't even count the data now, because it's not even it's counting in the days, not it's counting in the minutes, not in monthly data or quarterly data. It's in seconds and minutes. But RDBMS servers are costly, means it's for limited storage. It can tackle the data in terabytes, but not more than that. Okay, so which means that if we have the data more than or greater than terabytes, more data, then we have to scale the machines. Scaling the machine means what? If you have a machine with some RDBMS installation is done, you are tracking the data in that table. Now all of a sudden the data is growing very enormously, then you have to increase the disk capacity, correct? And even the CPUs, everything you have to increase. And also in today's business need, right, we cannot simply go with structured data. Nowadays we have unstructured data, logs, photos, XML, semi-structured data like XML, videos, everything. We cannot add all these in a schema as in table. But one more thing we have to notice is, even if we can store, we cannot retrieve the data fast in a quicker manner when we required it. You can trigger a select statement in Oracle, but you need to wait for that to complete. Sometimes it will take 10 minutes, sometimes 1 hour, or sometimes more than that. It's based on how much data you have in the database. So now this PySpark comes with advantages of by solving all these issues. What are the issues? Storing large amount of data, storing and processing the data, scalability, which means scaling up. We will discuss about this scalability and other things in the next slides, but the disadvantages of using the RDBMS are these things. And also we can use RDBMS for structured format only. Okay, or even if it's nowadays I can see even images can be uploaded, but the retrieval speed is very less in RDBMS, whereas it's very fast in PySpark. Okay, so coming to the next point, which is advantages over Hadoop. What is Hadoop? All of a sudden we were discussing about Spark, then RDBMS came, then what is Hadoop? First, in the market, right, when we have seen the disadvantages of using RDBMS, the first open source framework that came in the market is Hadoop. Hadoop is a framework, big data framework, which provides a smart distributed solution for handling and analyzing big data in quick time. So this is the open source framework that we have got. But what happened? Again, it has some disadvantages. Disadvantages like Hadoop supports batch processing only. Means already you should have some data already in somewhere, and even if it's real time also it will process in batches. And also limitation on the technology. Hadoop has very good component called MapReduce, but only Java developers can write code. Other developers like SQL developers, Scala developers, Python developers, they can't use Hadoop. So there is a limitation on technology. And issue with the small files. Hadoop generates small files, means for example, if you have 1 GB data, it will divide that into blocks, small chunks of data. How much is the each block size is around 256 MB, or 126 MB based on the configuration. So each 1 GB file or any kind of data that you are sending as input to Hadoop will be divided into smaller chunks of data, and then it will do the processing. Up to some extent, these are all actually advantages. Okay, in the current market trend, whatever we have seen with the huge data and also the issues with RDBMS, Hadoop will resolve all these things, but it has some limitations, like up to 4000 nodes you can scale, and also only batch processing and iterative processing. Iterative processing means for every task it will iterate over the nodes. So all these are limitations in Hadoop. Next, fault tolerance. What is fault tolerance? For example, you have 5 machines added in a cluster. Cluster means group of machines which will work for you. So one machine is mainly which you call it as driver, which will be taking care of all your processes. For example, you are writing a code and you are sending the code to your driver. What that driver does, it will take the requirement from you, which means the Spark job, PySpark job. There we would have mentioned the instructions in the form of code. You will say read this file, then it has 2 columns, sum up them and return. Maybe this is your code, just imagine. This driver, what it does is, it reads the set of instructions and it will analyze for performing this task how many workers we need. If we have a work, we need someone to work on that, correct? So how many such workers we need? It will decide and it will distribute the processes and it will get back the results and show it to you. Let's say you have such 5 workers for which the driver is giving the work. One worker died. Died means what? There might be a power cut, there might be some issue due to which that one particular worker has gone. So what will happen to the task which is performed by that gone worker? Do we lose the data? No, because Pyspark has very good feature called DAG, which is direct acyclic graph. What it will do? It will, when you are giving the instructions to the driver, it will generate that diagram. It's acyclic graph. Acyclic means one way. It will not go as cycling purpose. It's cycling way. It's acyclic. Whatever instructions you are giving, it will make that as a pictorial representation internally. Okay. For example, you need to read a data. It will create a node saying that it is like reading the file, and take 2 columns and perform the sum. Then this is called as transformation in Pyspark. Transformation means whatever work you do, anything it can be, that is called as transformation. So the DAG will generate the diagram as first node as read the file, and then next one is sum up them and then return. For example, in this, if some node dies, some worker died, we have the DAG already, right? So it will just it will read that again. It will perform the same operation from where it failed. Because of this, we will never have data loss using Pyspark. And one more thing is, if the driver knows that it is failing, how it will know? Based on the heartbeat. Heartbeat means it's a signal. Signal which is given by worker. Like worker gives signal for every 3 seconds to the driver saying that I am alive, which means I am working on your task. If this signal is not received from any of the worker, then immediately the driver thinks that that node is dead, and it knows which task is performed by that worker, right? It will assign the task to another free worker. All these operations will be done internally. You don't have to do anything externally. This is just the underlying process about how PySpark or Spark works. Got it? So, fault tolerance means there is no data loss. If any failure, immediately it will recover. There is a concept called RDD, which is Resilient Distributed Dataset in Spark. So whatever you perform, whatever you create, like maybe reading a file or performing some transformations, you will be having some variable or constant in any other technology that you might be seeing, right? For example, if you create some variable, you will say int I, which is integer, right? So that is called as variable there. But here we have something called as RDDs, and anything that you create in Spark core is RDD, Resilient Distributed Dataset. This is the this component will make sure that this fault tolerance is reached for every task performing by Spark. So because of that RDD, that component and that uses, we will have fault tolerance in PySpark. Next, scalability. We have seen what is the issue with RDBMS, right? If the data is huge, you have to increase your RAM. You have to increase the disk capacity. How much you will increase? For example, if you are taking a laptop, they will say it has 2 slots for RAM and it is extendable up to 32 GB or 1 TB. But if your data is so huge, maybe 5 TB, then how will you use that machine? You have to add something, right? So you cannot vertical scaling means you will add something extra to the same machine. So that will become very costly. You have to have lot of external hard disk. How many hard disk you can add? There should be some limit, right, for any laptop or desktop that you use. So what this Apache Spark came up with, like horizontal scaling. For example, there is a driver that we just discussed, right? Driver is the main computer, and for that machine you can add any number of machines that you want. If you have 1 GB data to be processed, you take only one worker, and one worker means one machine. One more machine you will add to this cluster. Cluster means group of machines which work for one application, Spark application, one Spark application. Okay. So similarly, if you have 100 GB of data to be processed, you will add more machines. More machines means more machines with the RAM 1 TB. 1 TB or any kind of, based on the processing speed or the data that you are getting in, based on that you will add more machines to the cluster. So one machine has 1 TB, then you will add one more machine with one more TB. So the driver will distribute the tasks to each and every worker, right? So they will all be individually running their tasks. Because of that, the processing speed will be very high. That is the main advantage of Spark. It will distribute the data to workers, and workers will get the things done. The tasks that is given to them will be done, and they will send back the results to the driver. And all these will happen in memory, which is you already know that as RAM, right? In RAM it will perform the calculations. Because of that, that is the main reason for PySpark to be quicker than any other things in the market. In-memory computation is the very quicker and the best for computation. That's why PySpark is a very good engine and it is fastest in the market. So now, because of the scalability, we can add more machines to it to make the things done. Let's say there is one job to be done, anything, okay? If that job If one person is doing that job, how much time it will take? 10 minutes, let's say. If you give the same job to 10 persons, then it will be done by 1 minute, right? Because you are sharing the work, you are splitting the job into smaller tasks and you are giving to 10 persons. Then everyone will compute in maybe 1 to 2 minutes, let them take. But all these 10 people will come back to you in 1 to 2 minutes. Whereas if you give the same job to one person, he was taking 10 minutes. Similar way, the distribution will happen the similar way. The same job will be split into smaller tasks and it will be given to multiple workers. Workers means here multiple computers. So all these together will perform the task individually, will give the results back to you, which makes the overall job faster. The job duration will be very less because of this distribution of the tasks. Next, lazy evaluation. This is the main feature of Pyspark. Why? Because the name says lazy, right? And no one promotes laziness now. But what is the advantage is, in any technology you take, C, C++, Java, SQL, anything, if you are submitting a job from the line 1, the compiler will start executing the code one by one. Each and every line will be executed. In between, if you have some print statement or if you have something, okay, then what will happen? I mean anything, if there is a sum or some operation that is performed, and if you are storing that in a variable, the results will be stored in a variable, then what will happen is the results will be immediately sent back to the driver. Because of that, what will happen is you are executing the statements. Statements means whatever you write in the code. Each and every line in the statements will be sent back to the driver each and every time you get some results. Because of this, the network bandwidth between your worker node and your driver node will be high. Multiple times you have to, you means the compiler has to come back to driver and then back to the worker nodes, then again perform the processing, then again goes back to the main disk and then coming back. This process is going to take lot of time. Disk 6 will be high, network bandwidth will be high, apparently your job duration will be more. For this, Spark has come up with very good concept called as lazy evaluation. What is lazy evaluation? For example, you are telling some task, read the file. It will read and keep it, that's it. It will not do anything. It will just put it in the temporary location. It will not read. It will just create a logical plan for that. It's a plan. User asked me to read a file and that's it. It will not read. Next line you write the code saying you call the function called getting the sum of two numbers. It will create a plan and keep it, that's it. It will not do anything. Whatever, let's say you filter it after getting the sum, you say filter it where the sum is more than 20, let's say. It will create a logical planner, it will create a DAG and keep it, but it will never execute that. Then when it will execute, there is something called as action in Pyspark. Action means we are telling Pyspark when to take the action. For example, if you are asking show, there is a method called show and collect. Like that you have so many methods. If any of these actions are triggered, then it will go back and it will start performing the statements one by one. Until then it will not perform any of the tasks. It will just create a plan and it will be ready. Once you trigger the action, then it will start like a movie. Okay? So, because of this, what is the advantage? There will not be any unnecessary memory be used for any variables. There will not be any unnecessary, like maybe half it has done and after that if let's say there is some power cut issue or something, or some issue in the cluster, there will not be any such thing, because now once you trigger the action, it is doing that, it is performing the step by step transformations, and it will send back the results at a time. So instead of multiple disk seeks, it will collate the details for all the transformations that you have written before this action. At a time, it will send back the results to the driver. Because of this, only one time disk seek is happening, so the process, the job duration will be very less. And also we have the DAG. For any time we can go back and generate any record, any kind of transformations that we need. And because of the in-memory computations, it is very quicker to do so, because in the in-memory only it will hold that plan which needs to be done. So that's where the lazy evaluation will be very effective to us for increasing the job duration time, reducing the job duration time and increase the optimizations. So this is what is called as lazy evaluation. So these are the benefits for Pyspark that we see in the current market. Like, it is in memory computing, because of that the process will be very faster, and it supports both history data processing, batch processing, and real time processing. And it's polyglot, means we can write the data, we can write the coding in any of the languages like Python, Scala, R and Java. It supports like lazy evaluation, and the reading and writing of the files are very easy to manage, and there is no limitations on technology, and it has like multiple APIs which are called libraries, where even the SQL developer can work, even the Java developer can work. So like that we have multiple languages support provided by Apache Spark, and also we have multiple libraries included like Spark SQL, Spark Core, Spark Streaming, and Spark Machine Learning, Spark Graphs. In the same application, you can go back and forth, and you can import the library, and you can work on the code. For example, first you started using the RDDs, which is Spark Core. Then you notice you have some other in the same code you have to use Spark SQL. You just import the library and you can work on. In the same code you import a machine learning library and you can start working on the machine learning. So this flexibility is given only in Pyspark, Apache Spark. And Pyspark is the same Apache Spark with Python API for Apache Spark. With lot of these many advantages, Pyspark is the market leader in the market now. So with all these advantages, because of this we use Pyspark mainly for the data engineering. Hope this is informative to you friends. Thanks for watching. Please subscribe to our channel for more interesting learnings. Thank you.